Hey guys, welcome to another video in chemistry. In this video, I'm going to be working on naming molecules. So this video is a continuation of the video in which we discuss covalent bonds. So we're actually naming the molecules that are made via covalent bonds. So recall that with covalent bonds, we're mainly dealing with non-metals. So these are the elements on the far right of the periodic table. So there are three main sets of rules. There are three main sets of molecules that are made from the nonmetals. So that means there's going to be three sets of rules for each of these types. So this video is dedicated to the first set of rules, which is binary molecular compounds. The second set is binary acids. And an acid is any element that releases a hydrogen ion into it. And then we have oxyacids. Oxyacids are acids that have a polyatomic oxy anion attached to it. So just kind of go back to the previous, mentally go back to the previous section in which we talked about polyatomic ions. So, just imagine like a phosphate and then a hydrogen attached to the front of that phosphate, because when you put that into a solution, it releases a hydrogen ion. And that's technically what an acid is. All right, so like I mentioned before, we're going to be dealing with only the first set of rules, binary molecular compounds. So to keep these videos kind of not too long, I've decided that instead of making one long one with dealing with all the three rules, I'll just make three separate ones. So here goes for the first one. So let's just dive in and practice. Let's look at the first molecule, this first binary molecule. Again, binary meaning I'm dealing with two different elements. Now, two different types of elements, not necessarily just two numerically, because if you see here with the carbon, with the CO2 here, I have one carbon and two oxygen. That makes three elements. That's three numerical elements, but two different types. Okay, so when you see the word binary, like bicycle, two wheels, this is binary, meaning there's two atoms involved in here. So as I mentioned, this type of molecule has a specific set of rules, and I feel like they're pretty intuitive for what you see, because the first rule deals with the first element. So the first element in the formula is always named first, and you use the entire name. So as I'm naming this, now earlier I said I called this CO2, right? Now this element you're very familiar with, so you probably already know the name of it, but this is actually part of why I picked this one, because now we're kind of deconstructing it so you can see how the name actually comes about. So the first element, you name it in its entirety. So that's the first part of the name is carbon. And then the second rule deals with the second element. Okay, that's why I said these rules are kind of intuitive. So the second element in the formula is named using only the root of that word, and then you add IDE as a suffix. So the root of oxygen is ox, and then you add the suffix oxide, so carbon oxide. Okay. Now the third rule deals with the number of atoms, the subtext that you see in each element. Now with carbon, there's only one carbon, and here's one of the exceptions to the rules where you don't actually use a prefix, a numerical prefix, that is. Anytime that the first element has only one, you never use the prefix mono for the first element. So you're never going to say monocarbon, okay? Now with oxygen, there's two oxygens, and the prefix for two is di. So this is carbon dioxide, okay? This is carbon dioxide as opposed to monocarbon dioxide. And again, you don't use the mono. If there's only one element in the first name, you never use the prefix mono for the first element. So this is carbon dioxide. All right, let's get some more practice in here and look at another one, NF3. So again, remember, the first rule deals with the first element. You name the first element in its entirety. So the first part of this name is nitrogen. And then for fluorine, remember the root for fluorine is fluor. Okay, and then add the suffix IDE. So this is nitrogen fluoride. And then the third rule, you're dealing with the numerals, how many elements are involved. And remember, so for nitrogen, there's only one, but you don't use the prefix mono for one. And there's three fluorines, okay, so that's tri. So nitrogen trifluoride. That's the name of this binary molecule. Let's look at another one. So we have sulfur, for full name for the first element, fluor, as we mentioned before, and then IDE, fluoride, and there's 6, so the prefix for 6 is hexa. Okay, so that's sulfur hexafluoride. Now let's look for another one. This one you commonly know as water, H2O. So this is hydrogen. And then the second element, we use the root, ox, so oxide. And now for the third rule, we're going to be looking at the numbers. Now, if you notice with hydrogen, there's 2 hydrogens. So this is dihydrogen. And now there's only 1 hydrogen in the second, and you do use the prefix mono for that one, monoxide. So this is dihydrogen monoxide. That is the technical molecular formula or name for this molecule. Now, one of the things I want to draw your attention to is look at the monoxide. You see that M-O-N-O-O-X-I-D-E? Anytime you have a double vowel in the name, it's kind of it creates an awkward pronunciation, monoxide, and it's actually said monoxide. So anytime you have a double vowel like that, you can actually get rid of it and just have one of them. So it's monoxide, okay, rather than having the double O there. Okay, that does it for naming molecules. And this was just kind of scratching the surface at this. We will practice this even further in class. Stay tuned for the other 2 videos dealing with the other separate rules with acids and oxyacids. All right, guys, thanks for watching, and good luck in your study.